Hello, everyone. I selected 4 questions to work with on chain rule. So please follow me and have your paper pencil ready. Feel free to pause, forward, rewind, or play over as you need. And you are encouraged to do the question before you saw the solution, before you saw me doing it, or after you try to do it and just pause and try to do it by yourself. Okay, so the bottom line is that you can do it all by yourself. I selected these questions from this set of homework. Okay, that's the first one. The first one is right here, number 17 here. And the second one is 35. And the fourth one, capital F of t, is this number 31. And there's another one, which is a cotangent squared of sine theta, 37. Okay, so now let's get started. All right, we know chain rule, right? Chain rule is when we have composite functions that we have a strategy, we have a formula to differentiate. Look at this question of f of x, right? If we foil this completely, we're gonna have a huge polynomial with degree. Let's see, what would be the degree? That would be 10, 4, so degree number 14, okay, polynomial. So that obviously is going to be a lot of work. A lot of work is not the issue, is that it's made unnecessarily complicated. Okay, so we're going to use the chain rule. But before we use the chain rule, you can see this is a product of two functions. So we're going to actually have to use a product rule first. Okay, so first we're going to have f prime of x, right? So the derivative of 1, right? So basically this, I'm going to show you this. You basically write down these two, okay, product rule, right? You differentiate differentiate the first one, not changing the second one, and not changing the first one, and differentiate the second one. So that's application of product rule. Okay, that's product rule. You can also write it optionally, okay, that you put this in the front and you write derivative d of dx of this piece. Okay, you can see I switched the order because we want to avoid the confusion. Okay, plus, and this piece doesn't change, right? And we're going to differentiate the next one. So derivative of the second function. All right, so either way, the second way is optional. So if you write one way, you don't have to write the other way, okay? So either one is optional. I'm just showing you the different ways you can write it. I believe most of you probably write it this way. Okay, so I'm going to put it here and make this, in that case, you might like to write dy dx. Usually there's some kind of consistency there, okay? So either way you write is fine, okay? And next we're going to differentiate each one of the brackets. And then we get to apply chain rule. Okay, so how do we apply the chain rule, right? So the derivative of that part, so we first see it as, this is u, okay? So I'm going to pretend this is u. You don't have to obviously or explicitly introducing this u, but you see it as u to the power 4. So you're differentiating with respect to u, okay? You differentiated with respect to u. So you got 4 times u to the power of 3. Okay, just on that part. And then we know what u was, right? U was that, and you substitute that u back. Okay? Part 1. So that's we're doing this part, dy du. And then we're going to do du dx. Du dx, basically, the u is 2x minus 3. 2x minus 3. The derivative of 2x minus 3 is 2. And that part is done. And we copy the next part. We copy this part. Okay, this 2 is a result of differentiating 2x minus 3. So you can write it this way, okay? Plus, this part is going to be not differentiated. We're going to keep it, and now we're going to focusing on differentiating this part. The same idea. So this is our, if you want to call it v, right? You don't want to have the same name, okay? And you don't have to explicitly introduce v, but you know you are differentiating v to the power 5 with respect to v, okay? And that's like the dy over dv, okay? So that's differentiating v to the power 5 with respect to v. So that's going to be 5 times v to the power of 4. And then we're going to differentiate v, right? But before we do that, we're gonna substitute that v back. So these substitution doesn't have to be obvious, okay? As long as you see it with your mind's eye, that will be okay. And I think most of you are probably doing that, but if you have trouble with understanding this, please let me know. And next, we're gonna differentiate the v. We know what a v was. V was x squared plus 2 plus x plus 1. So that derivative is going to be 2x plus 1. So now the differentiation is done. Differentiation is done. And how much work we really need to show? You just, from here, the next line, do you have to show this part? You don't. You don't have to show that part, okay? And next, we're going to simplify. This simplification part sometimes is helpful for us to organize, okay? See, we have a number, right? We have 2 times 4, that's 8. We also have 2x minus 3 to the power 3. On the other term, we have 2x minus 3 to the power 4. And so we're going to factor out this lower factor. So this part is factored out. And x squared plus x plus 1 to the power 5, and this to the power 1, power 4. We're going to factor out the lower power, right? And in terms of numbers, this is a 4, 2, that's 8, and that's only 5. So we don't factor anything out. So we're going to, this one is out. 4 times 2, that's 8, right? Power 4 is factored out, so we still have one more. So 8 multiply that plus, okay? Power 3 is factored out, so we have power 1, so we have 2x minus 3 left. This part is factored out, and 5, it needs to be kept, right? 5 need to be kept. And last, we have 2x plus 1. Okay, so this is the factored part. It's being factored out. Next, okay, next, we are getting, we're going to keep the factors out. Okay. And we're just going to simplify inside the bracket. It looks like we can simplify the inside the bracket by multiply 8 with everything inside x squared plus x plus 1. So this is going to be 8, 8, 8. Plus, we're going to FOIL this piece. Okay, FOIL that piece. You can use scratch paper if you want. So 5, right? 5 multiply. So we're going to multiply 2x times 2x. That's 4x squared. 2x plus 1, that's 2x, right? Negative 3 times 2x, that's minus 6x. And negative 3 times 1, that's minus 3. And multiply 5 inside, right? So 5 times 4 is 20. 5 times 2, 5 times 2 is 10. 5 times 6 is 30. 5 times 3 is 15. And then we remove the parentheses, or you can do it on scratch paper or write a few more lines. I'm just doing it here, combining like terms. X squared, right? So that's going to be 28x squared. XC, so this is a negative 20, right? 8x, so that's going to be negative 12x, right? So that's going to be negative 12x. Okay. 8x, 18x, yeah, negative 12x. And these two makes negative 7. That's done. Okay, that's finished. So you can see when I check your work, when I check a student's work, right, on things like this, I would check that if you have each part, either this piece or that piece, either this piece or that piece. So this step is definitively checked. And the remaining steps, right, will also be checked. But this step, the first step of derivative, is essential. Okay, whether you set it up this way, I would check both. If you write both steps, I would check both, and your points will be determined on this step, All right, so that's application of chain rule. So let's look at the next one. On the next question, when we look at chain rule, that's cosine of a complicated expression. Okay, so I'm going to just make this screen a little bit longer because we see the questions and we have the chain rule. So when we differentiate dy dx, right, we're going to treat it, we're going to imagine this as u. Okay, not explicitly, but in my mind, this is u. Okay, so I'm going to differentiate cosine. Okay, so in my mind, this is what's going on. So this is a u du, right? So we're looking at that part, multiply du dx. Du dx. And my u certainly is that piece. Okay? Or you can write it here as over here. Do you have to write this step explicitly? You don't have to. You don't have to. But if you write it explicitly, you would write it this way. It's an optional step. Or you can go straight to just write it's a negative sign of u. Negative sign of u. And this time I can replace the u by what u was. Okay, u was this piece. And this is together. Okay, this is together. You cannot separate them. You cannot separate them. Sign of that parentheses okay? So you don't really need this step. So I would write this expression as optional, okay, optional. And then we're going to differentiate this quotient. We're going to differentiate this quotient. And this quotient rule applies, okay? So denominator squared, right? Differentiating the numerator, we're differentiating 1 minus e to the power 2x, right? Derivative, multiply the denominator's unchanged. Okay, so I'm setting up the quotient rule. If you don't remember the quotient rule, please bring that card with you. And the next one is pretty much the same product, right? Instead of differentiating that one, I'm differentiating the other one. Quotient rule. You differentiate the numerator first, keep the denominator, and keep the numerator differentiating the denominator. You can write this way, okay? And next, okay, the first part is done. So we just focus on the derivative of this part. When we differentiate 1 minus e to the power 2x, that's difference of derivative and also chain rule. And the derivative of 1 is 0, right? Derivative of 1 is 0. And the derivative of e to the power of 2x, right? So let me put it on the side, okay, pretending this is our scratch paper. So when we are differentiating this, so some of you probably just do it on the scratch paper, or you just do it right away, okay? So you're gonna get 0, and then minus e to the power 2x, differentiated, right? Oops, outside. E to the power 2x, differentiated. What does that equal to? So differentiating, this is a chain rule again. So you pretend it's e to the power u. The derivative of e to the power u with respect to u is e to the power u. So it's negative e to the power of u, which is 2x, right? And differentiating 2x, you get 2. Okay? So the derivative of e to the power 2x is 2 times e to the power 2x. So you just take this whole thing, right? You can put the 2 in the front. And you take the whole thing to replace that. And you do the same for 1 plus e to the power 2x. So this is turning into 1 plus. So this is a plus. So this is a plus. The second one, when we differentiate that, we get this piece to replace the derivative of 1 plus e to the power 2x. Okay, so by this time, derivative is done, and we just have to simplify the latter part, okay, the other factor. Each term has 2 times e to the power 2x. So I'm going to factor them out. So I'm going to factor this out. I'm factoring this out. Okay, so 2 times e to the power 2x, 2 times e to the power 2x is being factored out. Okay, inside the parentheses, what do we get? We're going to subtract 1, open up the parentheses, right? Negative sign apply to 1, minus, and negative sign apply to 1, minus, and this is a plus. Okay? And reduce e to the power, positive e to the power 2x, take away negative e to the power 2x. And this will make -2. -2 times 2 is -4. -4. When we write it this way, it's all right. And last, we want to express our answer. Of course, this is already answer. You can put this to the front. Okay. Also, you can notice there's a negative sign here, there's a negative sign there, right? So these two negative signs are, multiply becomes positive. And you can bring this, the factor in the back to the front. And remove the dot. And this is done. Can we reduce it? No, you cannot. We cannot combine these. We cannot combine this denominator with the inside of sign. We cannot. So this is the final answer. This is the final answer. Okay? All right. Chain rule. That was the question. Okay. So let's look at the third one. Let's look at the third one. Okay, so I'm going to put this under. Right? I'm going to put this under for our use, right? So the derivative of capital F of t, the derivative of capital F of t equals to, and obviously we have e to the power t times sine 2t, right? Can we, yeah, we're going to pretend this is u, right? So the derivative e to the power u with respect to u, something like this, okay? Derivative u, right? So e to the power of u, right? So I'm going to replace it by u, multiply u dx. Or you may like to put it in parentheses. Or you can put it on the side. Okay? All right. This step, once again, is optional. It's optional. Okay, but this is the process we can read, and this is exactly this part. That's the derivative. Okay. As I said, this step is optional. Okay, the derivative of e to the power u is the same as e to the power u, and you just replace u by what u was. Without parentheses, parentheses is not needed. And then we're differentiating this product. We're differentiating this product, okay? The dot is optional, but I put it there just to leave space. So the derivative of t, right? So derivative of t. So basically, we are applying product rule. We're applying product rule, okay? Differentiating t or differentiating sine 2t. So that's the situation. That's the situation we're in. You can write this step, or you don't write this step, you go to the next. Okay, so this is optional. Okay, let me just write it down. Because a lot of you do ask, how do I show work? How much do I want to see? This is optional. And this part is optional. Okay, that part is optional. Okay, this part is optional. You can replace this part by the next step. The derivative of t is 1. Sine 2t stay the same. T, no change, and we differentiate sine 2t. Okay, and this is going to be applying chain rule. So I'm going to put on the side how I would differentiate that, right? So we pretend that 2t is the u. So sine u with respect to u. So that's the cosine 2t. And then we differentiate 2t. The derivative of 2t is 2. It's better to write this 2 in front of it to avoid confusion. So this is the derivative of sine 2t. Now we're going to replace this part by it. So you can go straight here, and you don't have to show this separately, okay? Unless, or you can work it on your scratch paper. So you can actually show your work like this, okay, by the way. But as you're getting better, you're going to do this, that piece, and that. That's your first line of work. That's totally okay. That's totally okay. I'll get it. And next, we'll just do a little simplifying. We can remove the dot if you want, right? And put here, we can replace it by parentheses actually, because there's no parentheses, right? 1 times sine t is sine 2, 1 times sine 2t is sine 2t. And here you just write 2t. And we're done. We're finished. We're finished. Okay. Last but not least. Cosine, a cotangent. Cotangent squared. Okay, so note, I'm going to put a note here just in case anyone doesn't know. Okay, when we write a cotangent squared of something, okay, whatever, it means is a cotangent omega multiply itself. That's the meaning. I.e., it means the cotangent omega squared. This is the same for sine, right? It's the same for sine, right? So that's going to be sine. It's also the same for cosine. So you got it, right? So you got it. Cosine, right? They all mean the same thing. So that's notation. So let's go back to cotangent. So that's the meaning. That's the meaning. Cotangent. So differentiating cotangent squared is really cotangent something squared. Okay? So the u is really cotangent. So we're differentiating, right? So we're doing this. So derivative of y dy dx, right? So the first part is du. So what do we have? The u is really cotangent of sine theta. This is the piece. So we're differentiating that. Okay, so our u is this piece, and the u is that. Okay, I want you to understand that. Okay, once you understand that, right, even though you understand that step is optional, so this is going to be 2u, right? I'm going to replace u by what u was, right? We don't need the parentheses anymore. And we're differentiating cotangent. We'll call it differentiating cotangent. And what's the derivative of cotangent? Do we know that? Does everybody know that? I hope so, right? Is cotangent, that's the, I think the formula was somewhere. Wait. The formula, oops, I think I need to go backward. Right? The derivative of cotangent is cosecant squared, right? So we're going to differentiate in cotangent first. That's cosecant, cosecant squared of sine theta, right? So that was our V, and we differentiate sine theta, that's going to be cosine theta. Oh, you know what? I should write theta here. My bad. So this should be theta. Okay, we're so used to x. You know, sometime in this, well, in this case, it's theta. Okay, so that's one entity, and that's the other entity. Whoops, I missed the negative sign, right? So I'm gonna put a negative sign in the front. And we're done. We are finished. We are finished. Can we reduce it? No, I don't think we can reduce it. This is one entity, okay? And this is another one entity, okay? And cotangent sine theta, cotangent of sine theta is also another entity. So we cannot reduce it even further. That's all for this lesson or clip. Thank you for following me. Thank you.